All right, let's talk about one of the toughest challenges in AI today, fairness. How do we actually make sure the systems we're building are trustworthy and not just accidentally baking in all sorts of hidden biases? Well, that's what we're going to break down right now.
It's a tough question, right? But it's one that anyone working with AI has to ask. Because bias can be hiding in plain sight, quietly making unfair decisions that have huge real-world consequences. So the real question is, how do you find it and what do you do about it?
So here's our game plan. First, we'll talk about why bias is such a hidden danger. Then we'll get to the root of it all, which, you guessed it, starts with data. After that, we'll get into the nitty-gritty of testing a model for fairness, how to keep an eye on it and fix things, and finally, we'll wrap it all up in what we're calling the cycle of fairness.
Okay, let's kick things off with the big picture. Checking for bias isn't just some technical task or another box to check for compliance. Honestly, it's a non-negotiable part of building AI responsibly and ethically.
And here's the most important thing to get. Fairness isn't something you can just tack on at the end. It has to be a process. It needs systematic, structured checks at every single stage of an AI's life, from the moment you gather the data all the way to long-term monitoring after it's out in the world.
So where does bias even come from? Well, more often than not, you can trace the problem right back to the source, the data itself. Let's dig into how bias gets built in from the very beginning.
You know, an AI model is only as smart as the information you feed it. And if that information reflects our own historical injustices or societal prejudices or even just simple imbalances, well, the model is going to learn those exact same biases. It's the classic garbage in, garbage out problem, but with seriously discriminatory results.
To fight this, you basically have to become a data detective. You've got to ask the hard questions. Are all the different groups in society represented fairly in this data? Is data missing for certain subgroups, creating blind spots? Does the data reflect old injustices that the AI might accidentally learn are okay? Answering these questions is your first real step to fixing bias at the source.
And this right here, this is a perfect picture of the problem. If Group A makes up 80% of your data, the AI is going to become an absolute expert on them. But what about Group C with only 5%? The model barely has enough info to learn from, which almost guarantees it will perform poorly and make unfair decisions for that group. This is what data imbalance looks like in the real world.
And that's the real magic of doing this homework early on. By digging into the data first, you get a super clear picture of where the landmines are. You can spot the risk of unfairness before you've even written a single line of code for the model, which saves a ton of time and prevents real harm down the line.
Okay, so you've done your homework on the data. You've trained a model. Now what? Well, the next step is to put that model to the test, specifically to measure just how fair it is with real precision across different groups of people. We do this using tools called fairness metrics. You can think of them like specialized rulers. They're not measuring how accurate the model is overall, but whether its performance and its decisions are actually equitable when you compare, say, one demographic group to another.
Now, there are a few different metrics, because, let's be real, fairness can mean different things. Demographic parity, for example, checks if things like loan approvals are happening at the same rate for everyone. Predictive parity checks if the model is just as accurate for all groups. But a really crucial one is equalized odds, which asks a simple question. Are the mistakes the model makes happening equally for everyone? This is so important, as you're about to see.
Let's make this super concrete. Imagine a model for loan applications. A false positive is approving a loan for someone who ends up defaulting. Okay, the bank loses some money. That's a business risk. But a false negative, that's denying a loan to someone who is perfectly qualified and would have paid it back. That's a person who was unfairly denied a huge opportunity. If your model has a way higher false negative rate for one group of people, you've got a massive fairness problem.
So you've tested your model, and it's looking pretty fair. Time to launch it and call it a day, right? No way. The world is constantly changing. Data drifts and bias can creep right back in. Fairness isn't a one-and-done deal. It's a continuous loop of detection and correction.
This means you've got to set up a solid monitoring system. You need automated pipelines that can flag weird behavior, dashboards that let you see those fairness metrics over time, and critically, alerts that go off the second a fairness level drops too low. It's literally like a smoke detector for bias, always on, always watching.
And when that alarm does go off, when bias is spotted, the fix can't be some kind of band-aid you slap on at the end. The real solutions, the mitigation techniques, have to be planned and built right into your development workflow from the start. You basically have three main windows of opportunities to step in and fix things. You can do it with pre-processing, which means you fix the imbalanced data before the model even sees it. You can do it with in-processing, using special algorithms that actually prioritize fairness while the model is training, or there's post-processing, where you can actually adjust the model's final decisions after it makes a prediction to correct for any bias you've seen. Having this whole toolkit ready to go is absolutely key.
So as we pull this all together, you can see it's not a straight line from A to B. It's a continuous loop. That initial data deep dive flows into testing the model, which leads to that constant monitoring out in the wild. And when that monitoring flags a problem, you mitigate it, and the cycle starts all over again. That is the cycle of fairness, and it's how you make trust a core feature of your AI, not just an accident.
At the end of the day, this entire process really boils down to one thing. It's all about making sure that these models stay equitable, compliant, and fundamentally trustworthy from the day they're born to the day they're retired. This isn't just about good ethics, it's just good, smart practice.
And that leaves us with one final thought. Now that you've seen the whole cycle of checking for bias, from the data to deployment and all the way back again, what's one step, maybe it's big, maybe it's small, that you can take to champion fairness in the systems that you build, that you use, or that you oversee?